Hi, welcome to the another lecture on DIAC. DIAC, the expansion of DIAC is diode alternating current. Now we see the symbol of DIAC. DIAC, the symbol is it has two diodes connected in parallel in opposite direction. Now we have two diodes, right, connected in parallel and in opposite direction. Then consisting of two terminals here, so we call these two terminals as main terminal. So it has been written as anode 1 and anode 2, and it is better to call that as main terminal, that is MT1 and MT2. So DIAC has two terminals, MT1 and MT2. Now the DIAC terminals can be reversible. That means we can have these terminals either MT2 or MT1 or MT1 to MT2. It's our wish. It's depending upon our usage. We can change the terminals, right? Like the resistor and the capacitor, we try to change as bidirectional. So this is a bidirectional device. Now we see the construction of this DIAC. So the DIAC, now here in this figure we have the two constructions actually. Now the first one with MT1 given to the positive terminal of the battery and MT2 is given to the negative terminal of the battery. Now here if you can see here, now you can check that the construction of the diode will be like the construction of a transistor, but it has many layers, right? Now here we can see it has N1, P1, N2, P2, N3. So you can count how many layers it has. So 1, 2, 3, 4 and 5. So DIAC has 5 layers. So it has, now DIAC is an 5 layered structure. It has 5 layers. Okay. Now depending upon the requirement, where considering that MT1 can be connected positive and then MT2 can be connected negative. Now this is the flow of the current. So the current will be flowing from MT1 to MT2. And now if you reverse the battery, that means if you make MT1 to negative and MT2 to positive, that means if you connect the main terminal 1 to the positive of the battery, positive potential of the battery, and negative terminal of the battery, and MT2 to positive terminal of the battery, the current will be flowing from MT2 to MT1. Okay. Now the next another point here is that we can see, right, what happens. Now this is the construction and its working principle. We can see when we can see when we connect MT1 to positive and MT1 to negative. Now the layer we take only P1 as the P1 to be considered. So P1 to N2 will be forward bias and NT to P2 will be reverse biased. Okay, and similarly here N3 to P2 will be forward biased. So here what happened here is, here N1 will not be considered, right, because this particular MT1 will be connected to both the N1 and P1 here. So P1 will be active and the current will be flowing from P1. Fine. And similarly in the other case, in the last figure we have MT2 as positive. When MT2 as positive, we take P2 into consideration, so we neglect N3. So here when M22 is positive, P2 to N2 will be forward bias, N2 to P1 will be reverse bias, P1 to N1 will be forward bias. So the current direction will be from P2 to N2, N2 to P1 and P1 to N1. Now why this construction is and what is the use of this? Now if we can see the use of all this, right, now we can see the use of this, and now this slide shows whatever I told you, that whenever you connect MT2 to MT1, positive to negative, the current will be flowing. Now we directly move on to the VI characteristics of the DIAC, where you can understand better. Now this is the VI characteristics of the DIAC, where you will be having MT1 connected to the positive terminal and MT2 as the negative terminal. Now when you connect, what happens is that you will be applying a voltage from MT2 to MT1, and then the current will be flowing very slowly from MT1 to MT1. Okay, now the middle figure, the current, when you connect, the current will be flowing very slowly from MT1 to MT2, and the current here in between will be due to the leakage current, that is due to the minority charge carriers. So the current will be very minute, and that current uh, will not be very high. So the VI characteristic curve shows a very little increase, and this state is called as a blocking state. So this current is due to the minority charge carriers moving across. Now when a voltage, if you increase the voltage between MT1 to MT2, now at a particular threshold voltage, or at a particular voltage, the diode, that is diac will be turned on, and it will be breaking down, that is it will be in the, it will have a breakdown voltage will occur, and then the current will start conducting. So this is the curve showing the first quadrant of the VI characteristic curve. So the conduction takes place in the positive half cycle after a certain threshold voltage or the breakdown voltage. And similarly, this and similarly, if you reverse the polarities now, when you make MT1 negative, MT2 positive, and then the curve will be in the third quadrant. In the third quadrant, you can see similarly it will be having the blocking state, and then after a breakdown voltage, it will be started conducting. Right now, this is the conducting state for the negative half cycle of the diac. Right now, it has, right now, another point here is that the VI characteristics of the diac will be in the shape of a Z. Right, so we can notice that now this is the Z shape. If you can see in an angle, it will be like a Z shape. Right, so and the characteristics will be lying in the first and the third quadrant. Fine. And then it has two states. One is the blocking state, as I told you, and the other one is the conducting state. Right, so this is the working of the particular diac, and then most of the diac will have the breakdown voltage around 30 volts, and the exact breakdown voltage will be based upon the type of the device, and even it depends upon the amount of doping. The diac will be in the conducting state until the current reaches a particular value called the holding current, where the holding current is in the minimum current which requires for the device to keep it on. Right, so this is about the diac operation. Thank you, hope you enjoyed this video. So we will meet in the next video lecture, and we will see the triac operation. Thank you.